We're going to be starting our trig unit now for pre-cal, and in order to do that, we need to review a couple concepts from geometry. So that's what we're going to do today. And we'll start with the special right triangles. These relationships will be important to you as we move forward in trigonometry. Let's take some time to review and practice them. So the two that we're looking at here is the 45-45-90 triangle, which is this one right here, and the 30-60-90 triangle, which is this one right here. You should be able to get all sides of those triangles given any side. There's a pattern that goes with it. For a 45-45-90, both sides are exactly the same thing. We refer to them as x, and then the hypotenuse is x square root of 2. That's going to be true for all 45-45-90 degree angles, triangles. For the 30-60-90 triangle, the shortest side, the one that is across from the 30 degree, is x. The longer side, which is the one across from the 60 degree, is x square root of 3, and the hypotenuse is 2 times x. So we will look at a couple of triangles so you can see how that works before we move forward on our other ones. So here they gave us one side, 5, and told us it was a 45-45-90 triangle. Well, we said the two sides are the same on a 45-45, so this side would also have to be 5. Both sides are the same. So BC would be 5. For the hypotenuse, we said it is x square root of 2. That means this hypotenuse would be 5 square root of 2. Here's another example of that one. In this case, they gave us the hypotenuse, which was 3 square root of 2. Again, a 45-45-90. So if our hypotenuse, which we match up to this one, is 3 square root of 2, then we know that the x value is 3. So both of these sides would have to be 3. Now let's look at some of the 60-30-90 triangles. So in this case here, across from the 30 is a 4. So the shortest side is going to be 4. According to that pattern, that shortest side is x. So this tells me that x is 4. For the longest side, it's going to be x square root of 3. So this side would have to be 4 square root of 3. And that is KL. For the hypotenuse, it says it's 2 times x. So we would take this value, multiply it times 2, so our hypotenuse is 8. All right, this one's giving us our hypotenuse as 12. We know that across from the 90, which is our hypotenuse, is supposed to be 2x. So 2x is equal to 12. That's what the pattern is. If 2x is equal to 12, then that tells me that x is 6. Well, the shortest side, the one across the 30, so it would be this side right here, is then 6. That is ST. And then our longest side is x square root of 3. And so this would be 6 square root of 3. So once you know one side, you're going to be able to get the other ones using those patterns. So it's pretty important that you know this 30-60-90 triangle and this 45-45-90. We'll go ahead and look at one last one here. In this case, they gave us the longest side, which is the one across from 60. We know that that's x square root of 3. And so my x value has to be 2. So this part right here is 2. Our hypotenuse is 2 times x, and so if this is x, then that is 4. All right, we reviewed those 30, 60, 90, and 45, 45 triangles. There was some practice in your packet, so make sure that you practice a couple of those to make sure you learn those patterns. Now we're going to go ahead and review angles of elevation and depression in SOH-TOA. First, we'll start with the definition. An angle of elevation and depression, something that people confuse. So the elevation is to look up from the horizontal of the object. So there is a horizontal right here. The elevation angle would be the one that goes up from that horizontal. So it is not elevation from the floor here, it's elevation from that horizontal. And then angle of depression is to look down from that horizontal object. So it would be this one right here would be my angle of depression. Again, not from the top, but from that horizontal line. Here's another way of looking at it. Here is my horizontal line. The angle of depression would be this way. The angle of elevation would be this way. And that's important because if you remember angles that are congruent here, you can use that. All right, the other thing we're going to review is SOH here for our trig functions. SOH stands for sine, and that's opposite over hypotenuse. So the sine of theta is equal to the opposite side over the hypotenuse. CAH stands for cosine, adjacent and hypotenuse. So the cosine of theta is the adjacent side over the hypotenuse. And then TOA is our tangent, is opposite over adjacent. So tangent of theta is equal to opposite over adjacent. Those are the ratios that we find when we do our sine, cosine, and tangent. Just as a quick reminder, so you know what that means, we'll go ahead and draw a triangle here so you know what it looks like. And we'll use this as our angle of theta. The adjacent side would be this side right here, because it's attached to this angle. So that's our adjacent. The angle across from that would be our opposite side. And then our hypotenuse is always this longest side right here. So this is our hypotenuse. The opposite side would be this one right here. The adjacent side is attached. So that's how you're going to come up with the ratios for this. We will be using our calculator a little bit for these. Anytime we use those real world problems, we're going to use our calculator. So you do want to remember to have it in degree mode. So when solving application problems, using your calculator, always make sure what mode it's in. If we are using degrees, it needs to be in degree mode. This is a mistake that lots of students make. So if we're trying to solve something like this right here, the sine of 34 is equal to x over 72. As a quick reminder, sine is opposite over hypotenuse. That means we're looking for the side that is opposite. That means if we had a triangle here, this would be the angle at 34 degrees. Our x would be our opposite here, and 72 would be our hypotenuse. So we're looking for how long this side right here is. To solve this, it's a proportion, so we can cross multiply. And so we get 72 times the sine of 34 degrees is equal to x. This is where your calculator comes into play. So we're going to go to mode, and we're going to make sure that it's in degree. So I make sure that it's in degree right there, and then we can do our calculations. So our sine, cosine, and tangent buttons are right here on the calculator. So we're going to hit 72 sine of 34. Let me see where you can see that best. There you go. 72 times sine of 34, and then I close my parentheses. Be real careful with these parentheses. It does open it automatically when you're doing the sine, cosine, and tangent. We hit equal, and we're going to want to keep 3 decimal places at least. So this would be 40.262. All right, here's another one, tangent of 30 degrees. I'll go ahead and set up our triangle just so you see what's happening there. Remember, tangent is opposite over adjacent. So my adjacent would be x, my opposite would be 55. And so this is what we're looking for in this particular case. That's why they use tangent, is because they had the opposite and the adjacent. And so to solve again, we would use cross multiplication, and we get x tangent of 30 is equal to 55. Now we're trying to get this x by itself, and these two are being multiplied. So I divide by tangent of 30. All right, so to put this in the calculator, we are going to do 55 divided by tangent of 30. And then again, I close my parentheses for that. And so we get 95.263. All right, to finish up our review of triangles and SOH, we're going to do some word problems. Drawing a picture on these is going to be a pretty important part. All right, it says the safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safe rescue height? All right, so we want to draw a picture here. So I'm going to draw my building. Definitely not an art teacher. I'm a math teacher, so keep that in mind. All right, so we are going to put our ladder against the building there. And we know that it is 110 feet. Now, this is going to make a horizontal here, and it told us our angle of elevation. So our horizontal part here, this would be the angle that they're giving us of 72 degrees. So it wants to know this side right here. So when we set this up, we're going to want to think about what we're looking for and what information they gave us. Obviously, we've got the angle. It is here. This X is the opposite side. So we have the opposite, and then we have the hypotenuse, which is on this side. The one that does opposite and hypotenuse is sine. So we would want to do the sine of 72 degrees is equal to the opposite, which is X, over our hypotenuse, which is 110. Now we're ready to solve for this. We cross multiply, so we get 110 times the sine of 72 degrees is equal to X. We go ahead and put that in the calculator, and we get X is equal to 104.62 feet. So that's the highest rescue that they can do. All right, a second example says a student looks out of a second-story window and sees the top of the school flagpole at an angle of elevation of 22 degrees. The student is 18 feet above the ground and 50 feet from the flagpole. Find the height of the flagpole. So we're going to have to think about this here. He is on the second floor, so that's going to be our horizontal. And it says it's an angle of elevation, 22 degrees here, to the top of the flagpole. So there's our angle of elevation off that horizontal. It said he is 18 feet in the air. So we already know that part is 18 feet. What we're looking for is this part right here. And it says it is 50 feet from the flagpole. So 50 is going to be that bottom part there. In this case, we have the adjacent and we have the angle, and we're looking for the opposite. So the one that is the opposite and the adjacent is our tangent. So we're going to set this up as tangent of 22 degrees is equal to the opposite over the adjacent. So that's going to be X over 50. We cross multiply. And then we put it in our calculator and we get X is equal to 20.20. Now in this case, we have to do a little bit more work because we were already 18 feet from the ground. So we need to add this 18 that's on the bottom here. So we would add 18 to the height because we just found this height. And so the flagpole is going to be 38.20 feet. You had to put a little more thought to that one. All right, we'll look at another example here. It says an observer stands atop a building 25 meters above the ground, and the angle of depression to a car on the ground is 27 degrees. How far is the car from the building? So again, we're going to draw our picture. That picture is pretty important so you can see what information you have. Our angle of depression, so we're looking this way at a car. Quick reminder, I'm not an art teacher. All right, so our angle of depression, remember, it comes from a horizontal line. So it is telling me that this right here is 27 degrees. But we know from geometry that if that is 27 degrees, then so is this. So now we've got our angle. It is saying that the building is 25 meters above the ground. So we know this side is 25. How far is the car from the building? So we're looking for this part. Now that I have everything labeled, I can figure out what I have. I've got this part right here that I'm looking for, which is the adjacent. I've got this part, which is the opposite, and then I've got my angle. So when it's adjacent and opposite, again, that's the tangent. So we want the tangent of 27 degrees is equal to the opposite, which is 25, over my adjacent, which is x. Now we're ready to solve. We cross multiply. And then we divide by the tangent of 27. Remember, that's all one term. You cannot separate that. We put that in our calculator and we get 49.065 meters. So the car is 49.065 meters away. All right, we'll do one last one. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, whereas the angle of elevation to the top is 53 degrees. Find the height S of the smokestack. So we start by drawing our picture. Here is my building. I'm going to go ahead and draw my smokestack on top of the building. And this one's a little bit harder here. It says at a point 200 feet from the base. So I know that this is 200. The angle of elevation to the bottom of the smokestack is 35. So this one is 35. Whereas the angle of elevation to the top is 53. So this whole angle is 53. Now that we have all of that drawn out, we can do our triangles. In this case, you've got to think of two different triangles. There's this one here, and then there's the bottom one. And we're going to subtract the two lengths in order to find how big is just this smokestack here. So tangent of 53 is x over 200. That's going to give me the entire length here. We cross multiply. And we get 265.409. So that's the total height from the bottom to the top. Now we need to find what the height is right here so that we can subtract it. So now we do the tangent of 35 degrees is equal to x over 200. Again, we cross multiply. And so this one is for the smaller part right here, the size of the building. So if I subtract the two, that's going to give me the smokestack. And so we get 125.367 feet. So this is just a review of TOA and your special right triangles before we get started in our trig unit.